right, our objective today is to simplify powers of I, simplify radical expressions, and to add, subtract, and multiply complex numbers. So we're going to start off with the definition of I. I is defined by the fact that I squared is equal to negative 1. In other words, I is equal to the square root of negative 1. So for our powers of I to the first is just going to be the same thing as I squared, we just said, was equal to negative 1. To figure out I to the third, we need two exponents that will add up to 3. So we're going to multiply I to the first times I squared, because 1 plus 2 would give us the 3. We know that I to the first is just I squared is negative 1. So we know that I times negative 1 would be negative I to the fourth, we need two exponents that'll multiply, or two exponents that will add up to 4. We could use 3 and 1, or we could use 2 twice. Both of them will give us the same answer. I'm going to use I squared twice. So that would be negative 1 times negative 1, which just equals 1. I to the fifth, we can choose any of these exponents that'll add up to 5. I'm going to use 2 and 3. You could use 4 and 1 if you wanted. I squared is equal to negative 1. I cubed is equal to negative I. Negative 1 times negative I will equal positive I. For I to the sixth, we want two things that add up to 6. Let's use 2 and 4. So we're going to have negative 1 times 1, which is negative 1. I to the seventh, we need two things that add up to 7. I'm going to use 3 and 4. So we have negative I times 1, which is negative I. And I to the eighth, let's use 2 and 6. I squared times I to the sixth would give us negative 1 times negative 1, which is positive 1. Hopefully you've started to notice a pattern. When I, negative 1, negative I, 1. I, negative 1, negative I, 1. Since we have a pattern that rotates every 4, we're going to divide the exponent by 4. And then we're going to kind of think about money. We're going to think about the change when we divide. The change is going to tell you which one in the pattern to use. So let's look at some examples. The first one, we have an exponent of 14. We're going to do 14 divided by 4, which will give us 3.5. So we're looking at the change, the cents, if you will. 50 cents equals 2 quarters. So we want the second in the pattern, as in I squared. What did I squared simplify? It simplified to negative 1. Therefore, I to the 14th will also simplify to negative 1. I to the 27th, so take 27 and divide by 4, and you'll get 6.75. 75 cents is 3 quarters. The third thing in their pattern was I to the third, which equaled negative I. So I to the 27th will also equal negative I. I to the 2,349th. Again, we're still dividing by 4. 2,349 divided by 4 will give us 587.25. 0.25 is 1/4, so it's the first thing in our pattern, so it's just I. The standard form of a complex number is A plus B I. We're always going to have the real portion of our expression before the imaginary part of our expression. So adding complex numbers is really easy. We're just going to combine our like terms. So 3 plus 5 will give us 8. 2i and negative 7i will give us negative 5i. And that's our final answer. When we're subtracting complex numbers, we're going to distribute the negative first. And we can get rid of the parentheses from our first expression. And now we can combine like terms. Negative 2 and negative 4 will give us negative 6. Sorry. 8i and 3i will give us 11i. When we're multiplying radicals with negatives, we need to make sure we simplify the negatives first. The square root of negative 10 is the same thing as the square root of negative 1 times the square root of 10. We said earlier the square root of negative 1 is I, and we can't simplify the square root of 10, so we're going to leave it as it is. Similarly, the square root of negative 2 will be I square roots of 2, and the square root of negative 5 will be I square roots of 5. So now we're going to multiply the three things outside of our radical, so I times I times I, which will be I cubed, and then the square root. We're going to multiply our three things under the radical, 10 times 2 times 5, which is 100. Earlier we said I cubed will simplify to negative I. The square root of 100 is 10. So we have negative I times 10, which is negative 10I. On to multiplying two complex numbers. We're going to double distribute or FOIL like we did on our review problems. 3 times 5 is 15. 3 times 4i is 12i. 2i times 5 is 10i. 2i times 4i is 8i squared. So now we need to start simplifying. We're going to leave 15 for now. 12i plus 10i would be 22i. And then earlier we said I squared was equal to negative 1. So plus 8 times negative 1. That's going to simplify to negative 8. And then finally we have two more like terms that we can combine. 15 minus 8 is 7. Bring down our plus 22i. All right, let's look at another multiplication problem. This time we have 6 minus 3i times 6 plus 3i. So we're going to double distribute or FOIL. 6 times 6 is 36. 6 times 3i is 18i. Negative 3i times 6 is negative 18i. Negative 3i and positive 3i will be negative 9i squared. When we go to combine like terms, 18i minus 18i cancel out, that becomes 0. So we have 36 minus 9 times, remember I squared is equal to negative 1. Negative 9 times negative 1 becomes positive 9. And when we add these together, we get 45. So what are some things you notice about the previous question? Hopefully you noticed that the middle terms canceled out, which made the imaginary part of our expression went away. Also, if you notice about the original problem, the parentheses, or what's inside the parentheses, were identical except for the middle sign. Because they were identical except for the middle sign, these are called conjugates. This is an important vocabulary word that you should know, conjugates. And these look like A plus BI and A minus BI. So they're identical except for the signs in the middle. All right, and our last simplifying problem. We have things outside of both parentheses, so we're going to distribute that individually. We get negative 3 minus I plus 8 plus 14I. And then all we have to do is combine our like terms. Negative 3 and 8 is 5. Negative 1, or sorry, negative I and 14I is 13I. All right, our last couple examples. Write the following in A plus BI form. So here we just have the number 9. There is no imaginary part of this number that we can see. So we can rewrite it as 9 plus 0I, showing that there are 0 imaginary in this number. Similarly, if we have just the imaginary part, that means the real part is 0. So you have 0 plus 3I. And now we're going to do a little working backwards. Rewrite negative 1 as a power of I where the exponent is between 25 and 33. For these, think back to your problems at the beginning when we were simplifying based on the exponents. If we want to get I to the negative, or we want I to a power to equal negative 1, well, we know that I squared equals negative 1, which means the exponent divided by 4 would have to equal something with a 0.5 on the end. So let's start with 25 because that's the beginning. 25 divided by 4 would give us 6.25. Well, we're looking for 0.5, so it can't be that one. Let's try 26. 26 divided by 4 gives us 6.5. That is what we're looking for. So the exponent that we're looking here would be I to the 26. Now, try and see if you can see if there's any other exponents between 25 and 33 that would also work. Hopefully you figured it out that I to the 30th would also simplify to give you -1. That's all for today. See you in class.